Flang update. It's a Fortran compiler for LLVM. What is Flang? Take the PGI front end, generate PGI IR, put it through our bridge, it goes to LLVM IR, goes into LLVM tools. We have our runtime library that has about 250 intrinsic routines and IO system. OpenMP runtime comes from LLVM. The goal for the project when we started a couple years ago with the DOE was to build a robust front end for Fortran that was a lot like Clang or LLVM, modern Fortran, modern C++, easy for people to get into, used OpenMP, and was very performant. And you'll see we've done a couple of those things, haven't done a couple more. We released it about a year ago, and we've been pushing changes into it ever since. We've done about 800 commits so far. We're keeping it up to date with the PGI proprietary source code. It's almost the same. There's a couple of things different. We had to have a CLA from the NVIDIA legal point of view, but our goal is really to get into open source and to have Flang be the first place we develop, and then we pull inside and use it like that. So that'll take a couple of years for us. We've set up GitHub, Slack, mailing lists. Our GitHub issues are a little too active. We probably have 250 bug reports so far. Some user errors, not all. You can find us there, GitHub, or you can just Google Flang, you'll probably find us. We show up right on top. We did just open source our math intrinsic libraries. And this is production quality stuff that NVIDIA has been using for a couple of years now. We've been working on it as PGI for maybe 10 years. And it's not just the scalar routines for sine, cosine, all the arctangents and all that, but it's also the 128-bit vector routines, 256 and AVX 512. And it really cooks pretty good. We did it for power and for x86. There could be a generic one. There isn't right now, as the ARM people told us. So we should work on that. And that's performance. And people want Fortran to run fast. And if you look at what we have here, this is spec FP rate 217 on a Skylake. It's pretty fresh. I think we ran it last month. And Flang is just a little bit behind our commercial compiler and quite a bit ahead of Fortran. You can see here's a set of benchmarks, and we've normalized 100% to GCC. You see that PGI does better, but so does Flang quite a bit. Then if you look at OpenMP, I don't know what's going on there, but Flang really kicks butt on Spec 2000 OMP. I haven't looked into that yet. And they're real competitive, just head-to-head with the commercial compiler and well ahead of Fortran there. We also have a OpenMP 4.5 implementation that maps to the host computer. So it's not offloading. We're working on offloading right now to the NVIDIA GPU, but you can run your OpenMP 4.5 codes on a CPU. We did get some feedback on our source code. We started writing this about 30 years ago, and our data structure is called integer. We have an LR parser. There's no hooks for tools to get in there. We take that parser and we go right down and we transform the AST. It doesn't look like the source code anymore. It's written in C. It's big. If you read the code, everything's an X bit. Do this with an X bit. Do that with an X bit. And the first one has to be hexadecimal. Second one's the ones that did it. The error messages are all right. The AST is lowered early. It's not source to source. But we do generate LLVM IR with printfs. So we're going to modernize all that. We're responding to that feedback. We're starting to rewrite it all, a preprocessor scanner in C++, and basically chunking it up into libraries so people can use it as they'd expect. And we are converting the back end to use C++ so we can use IR Builder. And that's it. Thank you. Thanks.